In this video, we're going to discuss loan payments, credit cards, and mortgages. And chances are you guys have either a loan payment for a car or a credit card, or some of you may even have a mortgage that you're paying for. And these are payments that usually we make monthly payments on. And so in this section, we're going to talk about the formula that we're going to use to calculate those payments. So far, in the previous videos, we've talked about simple interest. That's this formula right here. And to find the simple interest, that's you take your principal times the rate times the amount of time, and the T has to be in years. And just a quick review, simple interest is when you only calculate the interest based on the principal alone. Then we talked about compound interest, and compound interest is when the interest is calculated based on the principal and previously accumulated interest. Then we talked about continuous compounding, that's this formula. And then we talked about if we're saving money and we want to build up a nest egg, we would use that formula there. So just a quick review what these pictures mean. If I look at the picture for compound interest to help us understand what this formula represents, this here would represent some lump sum of money that I put into some kind of an account, and I sit back and I watch it grow to a bigger lump sum of money. Okay, so if you look at that picture left to right, look at it like a timeline. I start off with a small lump of money. I just deposit one lump sum and I sit back and watch it grow to a bigger lump sum. When we talked about the savings plan formula, these lines here that look like steps represent each payment. So each step is a payment. And so looking at this left to right, it looks like we're going up, so we're saving money. Okay, our amount of money as we make those payments increase to a bigger lump sum of money. Now, the last formula that we're going to talk about for loans, when we're making payments to try to pay something off, that's when, remember, we look at this left to right, we have a lump sum of money that we owe, and that amount decreases as we make those payments. So that's what these pictures represent to help us understand when to use these formulas. So this is the formula we're going to talk about in this section. Okay, so here's what our formula looks like with all the variables defined. PMT is the payment amount. Your P is the starting loan principal, or because we're talking about loans and mortgages, money that we owe, the principal is now going to represent the amount that we borrowed. The APR is your annual percentage rate, just as before. N is the number of payments periods per year. And remember, we have a difference between the little n, which tells us number of payment periods per year, versus the big N, which represents the total number of payments over the entire loan term. So, for example, just a quick refresher, if we are making payments monthly, little n would be 12 because that's 12 times a year. If we have 5 years to pay it off, that means we're making monthly payments for 5 years. So the total number of payments we would be making would be 60 because it's 12 times for 5 years. So that's 60. So just a quick refresher on the difference between little n and big N. Okay, in the first example, it says, suppose you have student loans totaling $7,500 when you graduate from college. The interest rate is 9% and the loan term is 10 years. We want to figure out what our monthly payments are going to be. So, define my payment. I'm going to do the principal, which is what we owe. That's the $7,500. I'm going to multiply it by the APR, which is 9%. And then remember, we want to put it in decimal form, so 0.09. And then we're going to divide by little n, which, because we're making monthly payments, little m is going to be 12. Then I'm going to divide all of that by 1 minus 1 plus the APR over 12, raised to the power of minus 12 times 10. That's minus n times y. Y is the number of years. And then I have to close my parentheses. Okay, now let's put this in the calculator. And we have to be very careful when we put this in the calculator to make sure we put our parentheses in the right places to get the correct value. So anywhere in the formula that we see parentheses or brackets, we need to make sure that we put those in on the calculator. So let's highlight those in red. So anywhere I see bracket, any kind of grouping symbol, I need to put that in on my calculator as a parentheses. And then additionally, if we have the older model that doesn't show our exponent being raised so that we know what's exactly in the exponent, we should additionally put the exponent in parentheses as well. Okay, so let's put this in the calculator. Okay, so I have 7,500. I'm going to multiply. After the multiplication symbol, I have parentheses. So I have open parentheses, then 0.09 divided by 12, and then close parentheses. Then I'm going to divide everything by, and then I have open parentheses, 1 minus, then open parentheses again, 1 plus 0.09 divided by 12, close parentheses. Now I'm going to raise this to the power of negative 12 times 10. So I'm going to raise it to the power of, and then I have to close my parentheses around my exponent, negative 12 times 10, close my parentheses. And then I have one more parentheses to close after the exponent. That's this one right here, the big one underneath in the denominator. And then I'm going to hit enter. And it's going to tell me that I have a payment of $95. And if we round to the nearest cent, because I have that 6 there, it's going to round up to $95.01. So that's going to be my monthly payment in order to pay off my loan of $7,500. Okay, the second part of the question says, how much will you pay over the lifetime of the loan? Well, the amount of money I pay back is going to be the number of my payments times $95.01. Because this is 10 years with monthly payments, that means I'm going to have 120 payments. So that means I'm going to pay $95.01 120 times to pay off my loan. So if I take 120 times 95.01, I put that into my calculator, I'm going to get $11,401.20. So for a loan that's $7,500, I borrowed $7,500, but I end up paying $11,401.20. So I can figure out what the interest is. If I take the 11,000 number and I subtract my loan, which is the 7,500, I get $3,901.20. So I paid almost $4,000 in interest for a $7,500 loan. So it's really important that you try to pay off your loans as soon as possible. The more you can pay towards it, the less interest you're going to pay in the long run. And another lesson in this is try not to borrow unless you absolutely have to. Okay, what is the total interest you will pay on the loan? We just figured that out. We kind of did part B and C together. Okay, part B asked how much would you pay over the whole lifetime of the loan? That answer is $11,401.20. And then we actually figured out what the interest was by subtracting from the loan amount, which is almost $4,000. Okay, in the last part of this problem, we're going to create what's called an amortization schedule. And this is basically a way to break down your monthly payment to see how much goes towards the principal and how much goes towards the interest. So that way, whatever goes towards the principal can be subtracted off and we can figure out what our new balance is. And what we're going to do is we're going to do this for the first 3 months. Okay, so for the first month that we start making payments, we have our total balance to start with. So we have $7,500. And when we find out the interest for each month, we're going to use the simple interest formula on whatever the balance is. Okay, so I need to take the principal, which is the $7,500. Let me make a note of this up here. Times the rate times the time in years. So since the rate for this is 9%, I'm going to multiply by 0.09. And then since this is 1 month out of the whole year, remember T needs to be in years, it's 1/12 of a year. So I'm going to put that in on the calculator and I'm going to get $56.25. So if you recall, our monthly payment is $95.01. So of that monthly payment that we made for the first month, of that 95.01, $56.25 of it goes towards the interest. So whatever is left over from that is what's going to be applied to the principal. So if I take 95.01 minus 56.25, I'm going to see that that's $38.76. So out of my entire monthly payment of $95.01, only $38.76 is actually being applied to the principal because we have so much interest that we're going to have to pay. So to figure out our new balance, I take my 7,500, subtract off what gets applied from the principal of my monthly payment. That comes off my principal, and I'm left with $7,461.24. And then what happens is we just repeat the process for each month. So the next month, our next payment, our balance is $7,461.24. We're going to multiply it by the 9% and then multiply it by 1/12 because it's 1/12, it's 1 month of the year. And so that will tell us, when I multiply that, the interest for month 2. So when I calculate that, that's going to be $55.96. Notice that this and this are a little bit different. The reason is we paid off some of our balance in the previous month. So our principal has gone down, so when we find the interest rate on the new principal or the new balance, the amount of interest is going to go down as well. So now to figure out how much goes towards the principal, if we have a monthly payment of $95.01, I'm going to subtract off what goes towards the interest, and whatever is left over is going to go towards the principal. So when I subtract that, I get $39.05. Notice that we said the interest is going down for each month, but then look, the amount that gets applied to the interest, so the amount that gets applied to the principal is going up now because we have less interest, which means we can pay more on the balance. So you'll see this pattern. If we go out more months, the amount of interest is going to decrease for each month, and the amount that's going to be applied to the principal is going to continually go up. Okay, now to find our new balance at the end of month 2, I take 7461.24 and I subtract off what goes towards the principal, which we said was 39.05, and that gives me a new balance of 7422.19. So that's my starting balance for month 3. So the last month, we're going to figure out the interest by taking the APR times the amount of time. This is 1 month, so I'm multiplied by 1/12. And for month 3, our interest is going to be 55.67. Which means then we can use that to calculate how much is going to go towards the principal or our new balance. So when I take 95.01 minus 55.67, I'm going to get $39.34. So notice, again, this amount that we apply towards the balance went up, while my interest for the month went down. As we pay it off, the interest is going to decrease, and the amount that we pay towards the principal is going to increase. Okay, now to find our ending balance at the end of month 3, I take my new balance, which was 7422.19 from month 2, subtract off what we applied to the principal for this month, and we get a new balance of 7382.85. Okay, in the next example, we're talking about getting a loan out to buy a car, and we're going to calculate different loan rates versus the number of years on the loan. And so we're going to do 3 different loans and compare them. Okay, so it says we're going to take out a loan for $6,000 to buy a car. And there's 3 different loans that the bank offers. We have a 3-year loan at 8%, a 4-year loan at 9%, and a 5-year loan at 10%. We're going to calculate the monthly payments and total interest over the loan term with each option. Okay, so for the first one, the 3-year loan at 8%, to find our payment, we're going to take the principal, which is the $6,000. We're going to multiply that by the APR. In this case, it would be 0.08 divided by 12, because these are monthly payments, all over 1 minus 1 plus 0.08 over 12, raised to the power of negative 12 times 3, right? That's my N times Y, the number of payments a year times the number of years. And we need to put that in on the calculator. So remember, when you put this in on the calculator, I'm going to highlight the parentheses. This is where your parentheses, whoops, I didn't mean that one. This is where your parentheses should go. Let me erase that one there. And then also, if you have the older calculator, make sure you put your parentheses around the negative 12 and the 3. Okay, when you put that in the calculator, you should get a monthly payment of $188 and 2 cents. Okay, now let's check this using our calculator program. I'm going to go to Apps and Finance, and I'm going to go to TVM Solver. Okay, now since this is 3 years, 12 times a year, I'm going to put in here 12 times 3. It's going to tell me my big N is 36. I'm making 36 payments. My interest rate is 8%. My present value is going to be $6,000. That's how much I owe. And I want my future value to be 0 because I want to pay off that $6,000 and owe nothing in the future. This is monthly payments, so I'm going to put in 12 down here in my PY and my CY. And I've got everything entered in except for my payment amount. So now I'm going to make sure my cursor is blinking on the payment, and I'm going to hit alpha and enter to solve. And it verifies that I've got 188.02 right here, 188.02. Okay, the second part that we need to do before we move on to the next loan is we need to calculate the interest for each option. So I'm making 36 payments of 188.02. So that means I have a total that I paid would be, let's see, if we put that in on the calculator, that's 36 times 188.02. That gives me 6768.72. That's the total amount that I paid over the 3 years. So now to find the interest, I gotta take the 6768.72 and subtract off how much I borrowed. So that means I'm going to pay $768.72 in interest with this option. So there's my interest, and that would be my monthly payment. This would be my total interest over the whole 3 years. Okay, now let's go to the next option. 4 years with 9%. So I'm going to take 6,000, that's still my principal, times 0.09 over 12, and I'm going to divide by 1 minus 1 plus 0.09 over 12, raised now to the power of negative 12 times 4. Now this is where I need to put my parentheses. I'll highlight it. And then for the older versions, make sure you put parentheses around the exponent. And when you put that in on the calculator, you should have a monthly payment of $149.31. So there's our monthly payment. Now let's calculate the interest. So I need to find the total paid. Okay, so if I paid 12 payments for 4 years, 12 payments each year for 4 years, that means that's 48 payments. So 48 payments times 149.31, that gives me $7,166.88. Okay, so now to find the interest, I'm going to take the total paid and subtract off my original loan amount, and that means I'm going to have paid $1,166.88 in interest. So because it's an extra year added on and my percent went up, it's going to be a lot more in interest. So far, if I can swing the payment of $188.02 it looks like so far the first option is the best as far as saving money. Okay, last one, I want to calculate the payment for each month for a 5-year loan at 10%. So I have 6,000 times my APR is going to be 10%, so 0.10. It's still monthly payments, so over 12. And 1 minus 1 plus 0.10 over 12, all raised to the negative 12 times 5 years now. Okay, so let's highlight where we need to put the parentheses. That way we remember to put them in on the calculator correctly. And when we put this in on the calculator, we should get a monthly payment of $127.48. That's our monthly payment for this option. So the total paid is going to be 127.48 times the number of payments. Since this is 12 payments for each year for 5 years, that's going to be 60 payments. So when I take 127.48 times 60, that gives me, let's see, $7,648.80. So I have to subtract that from the 6,000 to figure out what my interest is. So when I take the 7648.80, subtract the 600, or sorry, the 6,000, that gives me 1648.80 in interest. So comparing, stepping back and looking at this, as we go, notice as we go up in the number of years, since it's spread out over more years, our monthly payment is smaller, right? Notice that, let me do this in a different color here. Notice this is the largest monthly payment, then it gets a little bit smaller and a little bit smaller because it's spread out over more time, so the monthly payment goes down. However, the more time that you owe that money, your interest is going to go up. So notice that the interest for all of these increase with the number of years as well. So if you can swing a higher payment per month, it's going to save you in the long run a lot of money in interest. So that's something to definitely take into account when you are taking out a loan on something. Okay, next example says, suppose you have a credit card balance for $2,300 with an annual interest rate of 21%. You decide to pay off your balance over 1 year. How much will you need to pay each month? So we need to find our payment. So I'm going to take my principal, which is our $2,300, times our APR, which is 0.21, divided by monthly payment. So that's N is 12, and that's over 1 minus 1 plus 0.21 over 12. And this is 1 year, so my Y is 1, and it's monthly payment, so it's going to be negative 12 times 1. Okay, so highlighting this, remember where we put our parentheses. Okay, and then let's see, if we put that in, we should get monthly payments of $214.16 is what we should pay each month in order to pay off that balance with an interest of 21% each year. Okay, next example. Paul has gotten into credit card trouble. He has a balance of $9,500 and just lost his job. His credit card company charges interest 21%, compounded daily. So that means we haven't really talked about this yet. If it's compounded daily, then N is going to be 365. Okay, suppose the credit card company allows him to suspend his payments until he finds a new job, but they continue to charge interest. So if it takes him a year to find a new job, how much will he owe when he starts his new job? So this is over 1 year, and he owes, his principal is $9,500. Now, notice that it says in the problem, they suspend his payments. He's not making payments on this. So this is just one lump sum of money, which is the $9,500, that is growing by compounding daily, 365 times a day, or 365 times a year for 1 year. So this is not going to be one of our payment formulas. If we look back, let me open up our formula sheet. If we look back, if we have one lump sum of money that grows to a bigger lump sum of money that he's going to owe, that's going to be this formula here, right? Our compound interest formula, because he's not making payments. These are the formulas here that you use if you're making payments. So we're using this formula here, the compound interest formula. Because he's not making payments. It's just one lump sum of money that's just sitting there and growing for a year. So the principal is $9,500. The APR is 0.21. This is being compounded daily, so that's 365 times a year, and then 365 times 1 year. Okay, when we put that in on the calculator, that's going to be $11,719.23. So what this is saying is, if he doesn't make any payments for a year while he's looking for a new job, that amount of money that he owes the credit card is going to go from $9,500 to $11,719.23. Okay, now we're going to talk about mortgages. And this is one of the most popular kinds of loans. It's a loan that helps you specifically buy a home. And mortgage rates are generally lower than interest rates on other kinds of loans because the home that you're buying serves as a payment guarantee. If you fail to make the payments, then what's going to happen is the bank is going to take possession of the home, and that's called a foreclosure. Now, there are some things you need to take into consideration when you're purchasing a home. You have the down payment, and that's an amount that you pay up front, and interest is not charged on that amount. And typically, a down payment is usually between 10 and 20%. Then you have the closing costs, and that can be substantial. It just depends on what the terms of the bank give you. Let's see. So the first example says you need a loan for $100,000 to buy a new home. The bank offers a choice between a 30-year loan at an APR of 5% or a 15-year loan at 4.5%. Compare your monthly payments. The total loan cost. Okay, so we have the 30-year loan at 5%. And we have the 15-year loan at 4.5%. Okay, so let's figure out what our payment would be for each loan. Okay, so I take my principal, which is $100,000, times my APR over monthly payments, so it's, and it's 12. And then we have 1 minus 1 plus 0.05 over 12, raised to the power of negative 12 times 30, because it's 30 years. Okay, so let's highlight where we put the parentheses so that it helps us keep track of that. Okay. When you put that in on your calculator, you should get $536.82. Now, because this is a 30-year mortgage, that would be 30 years, 12 payments for every year. So that means I'm going to have 360 payments. If I multiply that by the amount of the payment, that means I'm going to be paying $193,255.20 in total. So I can find the interest by subtracting the total amount that I'm paying from the amount of the loan. So since we are taking out $100,000 for the loan, that means I'm going to pay a total interest of $93,255.20. Okay, now let's compare this to the 15-year loan at 4.5%. I take my principal, which is 100,000 times 0.045 divided by 12, all divided by 1 minus 1 plus 0.045 divided by 12. Raise that to the power of negative 12 times 15, because it's 15 years now. Let's highlight our parentheses so it helps us put it in on the calculator. Okay, when you put that in on the calculator, you should get a monthly payment of $764.99. Now, because this is over 15 years, then I'm going to be making 15 times 12 payments, which is 180 payments. And that's going to be of $764.99. So when I multiply that out, I'm going to get $137,698.20 that I'm going to pay in total. Which means since we borrowed $100,000, the interest on the 15-year loan is going to be $37,698.20. So if we look at this and compare, the 30-year loan has a smaller monthly payment because it's spread out over more time versus the 15-year. However, because it is spread out over more time, the more time you owe the money, the more interest it's going to accumulate. Notice that the interest is higher on the 30-year loan. So again, it's really important to take that into consideration. If you can afford a higher monthly payment, it will be better for you in the long run because you'll save quite a bit of money in interest. Okay, in this example, we're going to actually include the closing costs in with this problem. The previous one, we didn't really talk about the closing costs yet. Okay, we have two banks. We have Great Bank, and then we have Big Bank. Okay. Great Bank offers a $100,000 loan for 30 years at 5% APR. And it says the closing costs are $500. I'll just label it as CC for closing costs. It's $500 plus 1 point. Big Bank offers a lower rate of 4.75% over 30 years, but has a closing cost of $1,000 plus 2 points. And we're going to look at and compare each of the two options. Okay, I'll let you guys try it on your own, but for Great Bank, the monthly payment would be $536.82. So see if you can get that. For Big Bank, your monthly payment would be $521.65. So if you notice, you're going to save approximately $15 a month with Big Bank's monthly payment. So far, Big Bank is looking a little bit better than Great Bank. But now let's actually count in the closing costs. Alright, so closing cost is $500 plus 1 point. Each point represents 1% of the loan amount. So since 1% of 100,000 is 1,000, the 1 point is going to be worth $1,000. So the closing cost is going to be $1,500. Now, if we look at the closing costs for Big Bank, they're charging 1,000 plus 2 percentage points. So 2% of the mortgage amount, which would be 100,000, would be 2,000. So the closing cost for Big Bank is 3,000. Since you're saving $15 a month on 360 payments, that's a savings of $5,400. So if you take that $5,400 and subtract off the closing costs, you notice you're actually saving $2,400. But that's if you plan on staying at that house and you don't plan on remortgaging. If you don't plan on switching banks or moving, Big Bank would be the better option. However, if you anticipate moving and you don't plan on sticking out the entire loan, it might be better to pay the lower closing costs up front and pay a little bit more a month. So that's a decision that you would have to make based on your personal circumstances. But based on finances only, looking at the full 30 years, Big Bank would save you a little bit of money. So in the previous example, we talked about Great Bank, and they had a mortgage for 30 years at 5% APR. And we calculated that the monthly payment would be $536.82. Now, sometimes people will get out a 30-year mortgage, but pay more on it every month to try to get the interest down. So in this example, it's talking about that alternative strategy of taking out a 30-year loan but trying to pay it off in 15 years by making larger payments. So we want to see how much larger the payments would have to be in order to pay it off in 15 years. So we're going to use our payment formula. We have the 100,000 loan. Our APR is 0.05, and this is monthly payments. And we're trying to pay it off in 15 years. So I'm going to raise it to the power of negative 12 times 15 for the 15 years. And when I put that into my calculator, I'll find that my payments would have to be $790.79 in order to pay it off in 15 years. Now, there are some pros and cons to doing this, and that will be part of your mortgage project. So I'm not going to talk about that. That's something I want you to think about. And the last example, it says you have a choice between a 30-year loan that has a fixed rate of 4% and an ARM with the first year rate of 3%. Now the ARM, that stands for adjustable rate mortgage. And that means that the interest rate could change while you're in your loan term. There's a benefit to a fixed rate mortgage, is that your monthly payments will never change. If you do decide to go with the ARM, there is usually a cap that the rate cannot exceed. However, there is still that risk, even though you're starting at a lower rate at the beginning, there still is that risk that the interest rate will raise later on. So in part A, it says, neglecting compounding and changes in the principal, estimate your monthly savings. So for the ARM, if we multiply that by 0.03, now this is just an estimate. This is not including the compounding where we include the interest when we recalculate. This is just a quick estimate. If we take 100,000 and multiply by 3%, that means we're going to pay about 3,000 in interest. Okay, and then if we divide that by 12, that's about 250 in interest per month. The 3,000 would be over the whole year. If we go with the fixed rate, just an estimate, if I take 100,000, that's the loan amount, and multiply it by the 4%, that would be 4,000 in interest over the whole year. And then when I divide that by 12, that gives me about $333.33 in interest per month. Okay, so you would save about $83 a month if you go with the ARM. However, the ARM might raise to 5% by the third year. How will your payments be affected? Well, in year 3, you're paying more in interest. Per month. So although you paid less in the beginning, overall, you're going to end up paying more if it keeps increasing.